Welcome to August 24th LeetCode Challenge, Power of 3. Given an integer n, return true if it is a power of 3, otherwise return false. An integer n is a power of 3 if there exists an integer x such that n is equal to the power of x, or 3 to the x. So example 1 here, we have n equals 27. Is there a possible integer that we can make up x such that n is equal to 27? The answer is true if x is equal to 3. So 3 to the power of 3 equals 27. So return true. Example number 2 here, we have n is equal to 0. Is there any power of 3 that will make n equal to 0? The answer is false because there's no integer x such that n will equal to 0. For example 3 here, we have n is equal to 9. Is there any power of 3 that would make 9? The answer is yes, or true. Because 3 to the power of 2, where x is equal to 2, is equal to x will be n equal to 9. For our constraints, we have n's between negative 2 to the power of 31, and we have 2 to the power of 31 minus 1. Okay, solve this using without loops or recursion. So let's do the following. Say if we have the following: n is equal to 3 to the power of I, right, or x. If we were to take the log of both sides, we would have something, do some math actually. We would have log of base 3 of n is equal to I, equal to x just to say. And then if we were to solve for x, we would know that, say, if we were to do log of any number, say 10, divide that by log 10 of base 3, that would also give you x, right? So I'm going to use this logic here, or this mathematical concept, to know that n has to be greater than, return, n has to be greater than 0, and we do the following. So log base 10 of n divide float division by log 10 base 3. Now we know that x is a modulus of 1, and if we take that and that's equal to 0, then we know that x is a power of 3. So therefore, this should return true if x, or n, is equal to the power of 3. So that works so far. There you go. So n is a power of 3 if and only if x is an integer. So in so we could check the number as an integer by taking the decimal part right here and doing it with the modulus of 1 and check to see if that's 0. So a couple things we need to make sense of is that make sure that this is a float, right? And they could be we need to make sure that's log base 10, because if we do that, then we get what's called like an epsilon number, so like a minor, like a float division error. Time complexity is based on log 10, so Python's log 10 method. So it is an expensive operation with upper and lower bound time complexities based on the algorithm. So the information of log base 10 is actually dependent on Python itself. I don't actually know the specific details at the moment. Space complexity, we have a big O of constant space because we're not using additional memory. And yeah, there you go. Have yourself a great day.